Hello again from Digicool Things. Recently I published a video covering some PLCC packaged CPU chips that I'd received as a donation from Les Anderson. In that video I built a custom PLCC to DIP40 adapter to allow me to test the CPU chips in my existing 6809 CPU card. I've also made this adapter available on my Tindie store, just in case that's of assistance to anybody else. I also mentioned that I would add a project to my to-do list to make a PLCC version of my existing 6809 CPU card, at the same time taking advantage of the PLCC space saving to combine it with the ROM Expansion Card. This video is therefore a follow-up to present my now completed PLCC-based CPU card project. This project actually took me a bit longer than I originally thought it would, primarily because I dived into the project with grand thoughts of making a single, combined, dual-inline package or PLCC package CPU card, also allowing building with or without ROM expansion, effectively making it a version 3 update to the existing 6809 CPU card, to add the PLCC package CPU footprint to the existing dual-inline package footprint, also with PLCC based ROM expansion added to the existing dual-inline package ROM footprint. So basically an all options in one 6809 or 6309 CPU card. Because this made for a pretty busy PCB layout for my standard MECB PCB size, it also forced me to go to a 4-layer PCB design. Now this was a fun KiCad project to put together and lay out, but this is actually a good example of what can happen when you're working on your own and don't have a colleague to bounce your ideas off. Specifically, you can head off down the path of what you think was a great idea without first stepping back to sense check that what you're actually doing does make sense. So, after 2 days of PCB routing, when I was about 90% finished with my 4-layer all-in-one combination PCB creation, I finally took a moment to check the ordering process for the first prototype PCB manufacturer. It was only then that I realized that the little bit more expensive 4-layer PCB was actually going to cost me 4 times the price of my usual 2-layer PCBs. And even if I went to a higher production quantity, I was looking at 3 times the PCB cost. Only then did it dawn on me that anybody obtaining the PCB for their own build would either be building a dual-inline package CPU based card or a PLCC CPU based card, obviously not both. So, from an end user perspective, there is no real advantage to an all-in-one combination PCB that would justify the increased PCB cost. I think my desire to make it this way was purely from a simplified stocking inventory point of view, and of course the challenge. I then have just one PCB to suit both dual-inline package and PLCC package build desires. So roll on the next day and I started all over again on a 2-layer PLCC only CPU card, still enabling the combination of CPU card and ROM expansion card, but no longer supporting a choice of either dual-inline or PLCC packages for the ROM and CPU. This, of course, does mean a separate 6309 PLCC based CPU card being added to the available MECB cards, with the existing 6809 CPU card remaining. But, as I said, this does actually make more sense from a user perspective, and the additional PLCC CPU card PCB will cost the same as the usual 2-layer PCB price. In case you're curious about this journey I went on, here is a 3D PCB render of what my 90% complete 4-layer all-in-one combination PCB looks like. I think it's pretty nice, even a work of art, but it will remain as a 90% complete project, on hold for now, as I simply can't justify completing it and ordering any PCBs. So, here is the 3D PCB render of the eventual and more appropriate 2-layer new 6309 PLCC based CPU card. Okay, let's now take a look at the schematic. This is basically a mashup of the 6809 CPU card and the 1MB ROM expansion card, just with the CPU and ROM packages changed to the PLCC footprint and an update to the bank select switch that I'm using. The switch used on the existing ROM expansion card is quite expensive and only really available from a limited number of suppliers. It's a nice rotary coated switch, but I thought I could do better, so I spent some time researching the options and buying a few samples to check the quality. First off, I transitioned to a 6-pin 3-3 layout switch footprint instead of the existing 5-pin 4-1 layout. This provides a more mechanically robust solution, as the 4-1 pin layout does put extra mechanical stress on the single pin side of the switch mounting. In addition, I found that positive logic switches are more readily available than the negative logic variety that I had been using. A small downside of this change to positive logic is the need for an inverter when using the rotary coated switch in the common configuration of switching low address lines that are otherwise pulled high. Effectively, with a switch on, it connects the pulled high signal to ground, hence the reason why negative logic switches are convenient. However, this buffering with an inverter also has the advantage that with the switch omitted from the circuit, the resulting address lines are all driven low, or bank 0. So if ROM bank switching wasn't required, you could also leave out the rotary coated switch, using only the first bank of the ROM. Note that, as with the ROM expansion card, you can also choose to use 1 or 2 ROMs, depending on whether you need 8 or 16 switch banks of up to 64K each. So here's the first manufactured version 1 PCB. Let's put it together for its first test. And we now have our first assembled card. I think it looks really nice, with its PLCC socketed chips and a configurable 64K memory map, with your choice of the RAM and ROM space address mix. Okay, now that we have an assembled card, it's time to test it. First, I'll populate the ICs, starting with the TTL chips. We have the 748CT688 for the I/O bank allocation, then we have the 748CT73 for our external clock generator. Finally, a hex inverter for our bank select. Next, we have the 8-pin reset controller, the TC1232. Then our 64K SRAM chip. You'll notice I used 2 16-pin dual align sockets because it's a 32-pin skinny dip. Let's get that inserted. Now I'll insert the Hitachi HD63C09 PLCC CPU chip. always like the way PLCC chips click into their PLCC sockets. This just leaves our ATF16V8 glue logic PLD and of course our ROM. Oh, and also our crystal oscillator, which I'll install now. This is a 3 MHz rated C version of the 6309 CPU. However, based on past experience, I'm going to actually drop in a 16 MHz oscillator. So we're running overclocked at 4 MHz. With the oscillator in place, let's take a look at the PLD code. Here's the WinCPL source for our 6309 PLCC CPU card. Again, this is really just a mashup of the existing 6809 CPU card and 1 MB ROM Expansion CPU card. The only real difference from the 6809 CPU card is that I've substituted the lowest A10 address line input for our switched A19 address line to allow switching between our two 512 MB ROMs. Also, the previously unused third chip select output now becomes the second ROM chip select. I've created some commented out chip select logic for 56K RAM, 8K ROM and also 32K ROM and RAM memory maps. But for now, I've enabled the 48K RAM, 16K ROM address map. Okay, so let's get the PLD programmed. With the PLD programmed and labelled, I'll now get that inserted. This just leaves the ROM. For this, I'll just use the same ROM image that I used for the existing 1 MB ROM expansion card. This has the Assist09 monitor in bank 0 and 6809 extended basic in bank 1. This leaves 6 banks free in ROM 0 for whatever you might want to later add for easily accessible use. So let's get that programmed and one of the PLCC flash ROMs inserted on the card. Okay, here's my programmed and labelled PLCC ROM. Let's get it inserted into ROM 0. Now we're almost ready for our first test. First I'll make sure that we have the I/O bank select switch set to C0 as expected by existing ROM code. So that'll be switch 1 and 2, set to off. So address lines A15 and A14 are high and the rest are low for C0. I'll also install a jumper for our ROM read-only. And I think we're ready for our first power-up test. So let's plug her into our backplane. I've already put the PCB standoffs on, so it sits quite nicely. Now we're ready for our first power-up. Okay, here goes. And we have a successful Assist09 prompt. To be sure, I'll switch off and change from bank 0 to bank 1. Then apply power again. And we have a successful 6809 enhanced basic prompt. So I'm pretty happy with my first retro-friendly, through-hole only PLCC CPU card. In fact, I'd say it's my new favourite CPU card. If you'd like to build your own, you should now find it on my Tindie store, with the usual options of just the PCB, or there are various optional packs for the parts you may not already have in your parts drawer. That's it. Thanks for watching.